Question 11. The diagram shows part of the curve with this equation here. The lines x is equal to 1 and x is equal to 2 intersect the curve at P and Q respectively, and R is the stationary point on the curve. Part A, verify that the x-coordinate of R is 3 over 2 and find the y-coordinate of R. Okay, now if R is the stationary point, then that means we need to differentiate and then we equate to 0. So y here is equivalent to x, then plus. I can take this one up here using the rules of indices. This will be 2, then into 2x minus 1, then power negative 2. Now when we differentiate this with respect to x, here we shall get a 1. Then this one will drop down here. Then we shall have it multiplying with that 2. And then we reduce the power by 1, so it becomes a minus 3. Then times. You have to get the derivative of what is inside here, and then you multiply through. So that will be a 2. That is what we call the chain rule. Okay. So meaning this one is going to be 1. Now 2 times 2 times 2, that is 8. Okay. But since there is a negative here, then we shall put minus 8. Then this one I can take it down using the rules of indices. That will be 2x minus 1. Then power 3. Okay, now we know for sure that for stationary points, dy dx is equal to what? 0. So you get this 1 minus 8 out of 2x minus 1 cubed. We equate it to 0, meaning we shall have 1 which is equal to 8 out of 2x minus 1 then cubed. And then we can cross multiply. That means we shall have 2x minus 1 cubed is equal to 8. Then we can take the cube root on both sides. Not so? So if we take the cube root on both sides, this simply implies that we shall have this one going, and this one will give us a 2. Okay? So we shall have 2x here minus 1, which is equal to 2. Now, this is an odd power. So when you are taking the cube root, do not write plus or minus here. That one we do it for even powers. Okay? Because if I have like negative 2 to the power of 4, it gives me the same answer as 2 to the power of what? 4. But if I have negative 2 to the power of 3, this one will be negative 2 times negative 2 times negative 2, which is negative what? 8. But 2 power 3 gives us 8. So these two are not equal. So never put plus or minus when you are having odd powers. Okay. So what will be our x? That is 2 plus 1, which is a 3 divided by 2. Not so? So they say that verify that the x-coordinate of R is 3 over 2. And indeed, it is 3 over what? Over 2. Then they said that find the y-coordinate of R. So what you do from here, you just substitute that for x, which is equal to 3 over 2, then y is going to be substitute here. So we shall have 3 over 2, then plus 2, then out of, this is 2, then times 3 over 2, then minus 1, and then this one will be squared. So we shall have 3 over 2 here, then plus, what do we get here? When you multiply this one here, of course this one will go, then 3 minus 1, you will get a 2. Then 2 squared will be a 4. Then that means 2 over 4, you will get a half. Not so? That means here we shall have a half. Now 1.5 plus 0.5, you will get a 2. So that means y is going to be equal to 2. As simple as that. Then part B, find the exact value of the area of the shaded region. Now when we check back here, the area of this shaded region, we can actually see that this is a trapezium, right? So I can say area of this trapezium, then minus area under the curve, okay? From this point here to this point here, okay? So that is that. So we need to know the x-coordinates here, but the x-coordinate of R is this 3 over 2. Now, what is the x-coordinate of P? Well, it is here, 1 and then the 2. Perfect. And by the way, for the trapezium, if you are to find the area of the trapezium, you have a half h. Area of the trapezium is a half h into a plus b, where a and b are the parallel sides of the trapezium. So what is the y coordinate when x is 2? So this will be the value here. And then what is the y coordinate when x is 1? That will be the value here. Okay, so we need to get those values. So I'll go back here and I say at P, we know that x is equal to what? 1. Now what is the y coordinate? So y is going to be 1 plus, then 2 over, remember it is 2x minus 1. So 2, then times 1, then minus the 1 here, then we square. So this one will be a 1. So 1 plus 2, that will be a 3. Okay, that means P is 1, 3. And then at Q, okay, x is 2. So if x is 2, then what is y? So y is going to be x, which is 2, then plus 2 out of 2x. So that is 2 times 2, then minus 1, and then squared. This is 4 minus 1. What do you get? A 3, then square, that will be a 9. So 2 plus 2 over 9. So this times this will be 18 plus 2. That will be 20 over 9. So meaning this one will be 20 over 9. So Q, the coordinates of Q are 2 and 20 over 9. Okay. So our shaded area, like we said before, is equal to area of trapezium, then minus area under the curve. Area under the curve. And of course, we find area under the curve by integration. So area of the trapezium is going to be a half h, then a plus b. So what is the h? H is this one here. Okay, that is the distance, the perpendicular distance between the two parallel sides. 2 minus 1, that is a 1. And then a can be this smaller value, which is 20 over 9. That is the one we have gotten. And then this is 3. Okay, so when we go back here, then we shall say a half times 1, then into 20 over 9, and then plus the 3. Okay, then minus, this will be the integral from the x coordinate of P is 1, and then the x coordinate of Q is 2. And then the equation of the curve is x plus, then 2 into 2x minus 1, and then power negative 2. Okay, then dx. Okay, now from here, we can have 9 times 3. What is 9 times 3? That is 27. 27 plus 20, that one gives us 47. So we shall have 47. It is 47 here over 9. Now 9 multiplies with the 2, and then we get that as 18. So we shall have it all together as 47 over 18. Then minus, you integrate this one, take away the integral sign, and then you bring the what? The square brackets. So increase the power by 1, divide by the new power, then plus. The same thing we shall do here. This is 2x minus 1. Because the derivative of this one is done under chain rule. So after increasing this one by 1, then we divide by that new power. Then we have to multiply by the derivative of this one here. Because the derivative of this one here is divided in this one, then it finds the denominator and multiplies with it. So that's why we just say multiply by the derivative of this one in the denominator. All right. Then from there, we put the limits 2 and 1. Okay. Now we are going to have the 47 out of 8 minus, of course, this one will cancel with that 2 there, right? So this one is a negative 1. In fact, let me first simplify this. We can have x squared over 2, then minus, then 1 over 2x minus 1. Because this one is power, negative 1. So when it goes down, then the power becomes a what? A positive. You see that? Okay, now let's put these limits, 2 and 1. So we have 47 here out of 8, then minus, put the 2. 2 squared will be a 4 divided by 2. That will be a 2. Okay. Then from there, minus, again put 2 here. We shall have 4 minus 1. That's a third. Okay. A third, that is what we are getting here. Then this will be a half. and then minus 1. Not so. Because here we'll be having 2 minus 1, which is a 1. Okay. Then what do we get inside here? By the way, this is 18, not 8. Pardon me here. So let's look at this one. 3 times 2. That one will give us 6. Minus 1, that is a 5. So 5 over 3. Not so? Then there's a negative and a negative. That one will be a plus. First of all, a half minus 1, that is a negative a half. Then a negative here makes it positive, and then the negative here makes it again a negative, so minus a half. So altogether, what do we get here? 47 divided by 18, then minus 5 out of 3, then minus 1 out of 2. Then the answer becomes 4 out of 9. As simple as that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.